So today we're going to talk about units of weight and possibly some combined units if we get to it. Again, we're going to talk about standard units of weight, but before we get too far into it, we got to do a little bit of a distinction between, I don't know why my computer's making a mess, but between weight and mass. They are two different things. Weight is the force of gravity. Yeah, I don't know where that came from. Mass is the actual amount of matter in an object. Matter is just, the particles and stuff like that, the atoms and molecules and everything like that in the object. Why are they different? What really is the difference? So the big difference is how they're measured. A weight, like I said, is the force of gravity that exerts on the object. And the way force is measured is against a resistance. And what we usually use for resistance is a spring. So you have a spring, and you'll hang the object on the spring, and then it stretches the spring, and that spring is then hooked up. It's got a scale with an indicator on it. That indicator points at a numbered scale that tells you what the weight is, depending on how far it stretches the spring. Mass is measured using a balance, where you put the object you're trying to measure on one side, and on the other side you'll put like known masses. And you add known masses, and maybe put some little ones on here too to fill it up. You add known masses until it balances. And then you just, whatever mass is over here, this has to be the same mass. Now you might be looking at those thinking both of them involve gravity. What's the big difference? Well, weight depends on gravity. Now, throughout all of Earth, gravity is relatively constant, 9.8 meters per second. It's the rate of acceleration. But because of the shape of the Earth is not round. The Earth is actually kind of oval shaped. Now, if you think about it, when you spin something, it kind of stretches out. That's what the Earth is doing. As you spin it, it stretches out a little bit at the equator, and it's a little bit shorter going across the poles. Because of that, when you're at the equator, you're a little bit further away from the center of the Earth. Gravity is a little bit weaker. And at the north and south pole, gravity is a little bit stronger. So your weight will change a little bit if you go from the equator to one of the poles, but not huge, not a big amount. It comes out to like 4 or 5% is the difference. So if you're 200 pounds, you might change by 7 or 8 pounds. Not a big deal. If you go to the moon, however, where the moon has 1/6 of the gravity of the Earth, you will have 1/6 of the weight. So a 200-pound person would be like 32 pounds. But your mass is going to stay the same because the amount of gravity on here is going to change, but the amount of gravity on the known mass is going to change the exact same amount. So your mass will not change. Your mass is a constant. So in our standard measuring system, we have units of, the unit of weight, of course, that we're most familiar with is the pound. But there is a unit of mass. The unit of mass is called the slug. Most people are not terribly familiar with a slug. 1 pound is 32 slugs. Well, they were just kind of named after whatever. The slug was actually like a little lead slug that they used for
like
things.
one of those lead things over there next to you.
Similar, yeah. And so they threw them in the pile, and 32 slugs actually what balanced out what it was approximately a pound. In the metric system, what we're familiar with is the gram. Well, the gram is actually a unit of mass. We call it a unit of weight, and we use it as a unit of weight because we tend to interchange weight and mass when we're measuring stuff. Because on Earth, gravity, like you said, is relatively constant, so they're kind of interchangeable. There is a unit of weight in the metric system called the Newton. So anyway, what we're going to work on, we are going to do the standard units. And we're going to talk about weight mostly is the word we're going to use, but when we talk about weight, we're actually talking about weight and mass. And what we tend to do in most applications, now in pure science, in pure physics and chemistry, they use all 4 of these units because we're very precise. We try to be very precise. In practice, though, in engineering and in common practice, we tend to use a pound to refer to both weight and mass in the standard system, even though it really is just weight. And we tend to use the gram or kilogram to refer to both weight and mass in the metric system. So let's look now at our standard units of weight. I've already mentioned the pound, but there is a unit bigger than a pound. Can anybody tell me what it is? Dresden got it. A ton. How big is a ton? 2,000 pounds. Now, this is actually what's called a short or a net ton. 2,000 pounds. When you hear the word ton, 99.999% of the time, this is what they're talking about, is 2,000 pound net ton or short ton. But there is something out there called a gross or a long ton. A long ton, which is 2,240 pounds. Well, why would there be a difference? Well, you think of your paycheck, your gross pay and your net pay. Your gross pay, if you work 40 hours a week and you get $10 an hour, it'd be $400. That's what you earn. But we all know you don't actually get a check for $400. They take out all sorts of other crap. And what you actually get to take home is going to be maybe you might get like $300 out of that $400. And that's your net pay, is what you actually get to keep. There, yeah, shut off now. Sorry. So anyway, the same thing's here. The ton was originally used for measuring grain, for buying and selling grain. And you can't just throw a ton of grain on a scale. It has to be in some sort of container. So the tub that would normally hold a ton of grain weighed about 240 pounds. So the long ton or the gross ton was the ton of grain with its container, the tub. And the short ton was just the grain itself. But again, whenever you hear the word ton, you should be thinking 2,000 pounds. Just be aware that there is an alternative out there. There's the gross ton. Smaller than a pound. By the way, the abbreviation for pound is LB, because in trading grain, abbreviation PD would make sense for pound, but when you're trading grain, the abbreviation PD was already used for paid. You didn't want to mistake the two of them. So they used LB, which comes from the Latin word libra, which is the Latin word for pound. Get confused there. That's stupid. Small, well, but I mean, they needed something, so they used the Latin word. Smaller than a pound, we have ounces. How many ounces are in a pound? There are 16 ounces in a pound. Anybody know what, by the way, the abbreviation for ounce is OZ, which also comes from the Latin word for ounce, which I can't seem to remember right now. They decided to be consistent. Latin? Actually, up until about the 1960s, so before my time, but up until actually into the 1970s, in 4th and 5th grade, almost everybody was taught a certain amount of Latin, because most of your English grammar comes from Latin. So it's very common to teach Latin in the young grades. This is before my time. I don't know any Latin, other than what's written on my dollar bills, or coins. Smaller than an ounce, anybody know? This one sounds like it's a metric unit, but it's not. A dram. There are 16 drams in an ounce. Smaller than a dram, there are units like minims and grains that are used in medicine. We're not going to worry about those.
What is grams?
Grams is metric. The reason we don't talk about minims and grains anymore is they've kind of been absorbed into the metric system now. There's 60 minims in a dram. So a minim, I think like minutes, 60 minutes in an hour, 60 minims in a dram. A grain, so I'm trying to remember, what is it? 30 milliliters per ounce. I don't remember anymore. It's like 2 grains or something per dram or something like that. I don't quite totally remember it anymore. But it says it's been kind of absorbed into the metric system. They use it as a metric unit now because the grain was the apothecary unit for measuring medicine. They would sometimes use a dram. They might prescribe an eighth of a dram of medication for something for a really strong dosage. But a lot of times it would be, okay, you're going to get 30 grains or whatever of medication. So because that was so prominent in medicine, and the metric system has taken over medicine now. Everything in medicine is now metric system. You may step on the scale and it may weigh you and it may come up with 210 pounds or whatever. In the chart, it's going to be saying 80, 89 kilograms. Everything's done in kilograms, in metric now. There are units other than these that you could get into. Actually, it's 7,000 grains in 1 pound, if I remember right. Something like that. But anyway, there's like the stone. Anybody know what a stone is? Other than what Jason did last week? Anymore? Hence the like 18 gallons of water through your system. Anyway, a stone is 14 pounds. Something I want to bring up. You hear about it a lot when you're... Sorry, Jason.
You got the deal.
What's that?
I go pick up stone outside, 14 pounds.
14 pounds. You hear about it on the news all the time that gold has hit, $1,800 an ounce or whatever. What they're talking about there is not what we consider to be an ounce. Precious metals, gold, silver, and copper's actually been measured in regular pounds now because it's so common to sell copper. But, gold and silver, platinum, other precious metals are bought and sold in troy units, not standard units. Troy measurement, pounds and ounces are far from being standard worldwide. That's one of the reasons why they're so horrible to use for trading. A troy ounce and a troy pound actually were from the island of Troy in Greece. For some reason, that was established as the precious metal trading capital of the world, so their measurements were used. 1 troy pound is only 0.82 regular pounds. So it's smaller than a regular pound. However, 1 troy pound is only 12 troy ounces. So a troy pound is considerably smaller than a regular pound, but a troy ounce is actually slightly larger than a regular ounce. So kind of ironic there. But they'll never be tested on the troy units, but I wanted to put them out there so you know that. When you're hearing all this about silvers, price of silver is hitting $70 an ounce or whatever, they're not talking about the standard ounces that we're used to. So anyway, in the metric system. In the metric system, our unit of weight, or technically its unit of mass, is the gram, abbreviated G. Same prefixes. We have the decigram, which is 1/10 of a gram, centigram, which is 100th of a gram, milligram, which is 1,000th of a gram. Then we skip from thousandths to millionths. We have a microgram. Now, we saw that technically the abbreviation for micro is that Greek letter mu, so microgram would look like that. But because the medical field uses micrograms a lot, and that was one of the first fields to everything has to be keyboarded into the computer, there is no mu key on the keyboard, so what they use is MCG. So that's becoming a common Americanized abbreviation for micrograms, is MCG. Then going the other way, of course, you have decograms, DAG, hectograms, and kilograms. Then again, you skip from a kilogram being 1,000 grams. Then you skip from there up to the megagram, which is 1,000,000 grams. A megagram is often referred to as a metric ton. So you might hear there's 1 metric ton or 2,000 metric tons of grain or whatever being shipped. That's talking about a metric ton being 1,000 kilograms. Now, 1 kilogram is approximately 2.2 pounds, so a metric ton is approximately 2,200 pounds. So it's pretty close to a standard ton. Conversions in this metric system, of course, still just like any others, just moving the decimal points over, so we're not going to talk about it a whole lot. And just like all the other units in the metric system, the standard unit, in this case the grams, the milli, and the kilo are the ones that are most used. I have never seen hecto or decograms used at all for anything. I have seen decigrams and centigrams used a little bit in medicine, but not very often. It's usually milligrams. In fact, grams are small enough. A gram is just a little, about like a large paper clip is about the weight of a gram, mass of a gram. So that's a little bit of a small unit. So kilograms are really a popular unit for measuring weight or mass in the metric system. So anyway, that's the last of our units we want to get out there. The next step is to talk about compound units and how to deal with it. So I'm going to throw a challenge out there for you. If I were to tell you guys that I can throw a baseball 90 feet per second, at that rate of 90 feet per second, would you believe me? No? Is that fast? That is a good question. You know, remember, from first base to home plate is 90 feet. That's saying I could stand at first base, throw the ball, and it'd get to home plate in 1 second. Well, it sounds fast, isn't it? But is it? What units are we used to measuring speed in? Miles per hour, yeah. If we could change this to miles per hour, then we'd have a better idea of whether that's fast or not. To do that, we're going to do this, 90 feet over 1 second, like that. Now we can do our measurement conversions. Like we've kind of shortcutted them because we're so used to converting with the standard units. But when you hit this one, we kind of have to go through the process. We need to change feet into miles. So I'm going to put feet on bottom so that they'll cancel out. And we're going to put miles on top. What's the relationship between feet and miles? 1 mile equals 5,280 feet. Right? So the feet will cancel out there, and we've converted that to miles. But we also have to convert the seconds into hours. So to do that, seconds are going to have to go on top so that they cancel out. How many seconds are in an hour? Well, if we don't know, we can go to minutes. How many seconds are in a minute? 1 minute is 60 seconds. Very good. But that puts us in minutes. We want to be at hours, so we've got to go one more step yet. We're going to get rid of the minutes. Put minutes here. Put hours here. 1 hour is 60 minutes. Now the minutes cancel out. So now what's left here, once everything cancels out, is we have miles and we have hours. This will be miles per hour. So we're going to multiply. 90 times 60 times 60 is what, 324,000, I believe, miles. 1 times 5280 times 1 times 1 hour is 5,280 hours. So we have 324,000 divided by 5,280. What do we get? 60. What's that? A smaller number. Let me try this again. 3, 2, 4, 0, divided by 5, 2, 8. Oh, there we go. 61.36. So 60. Yeah, I know. I moved the decimal point over to make for it. It is 61.36. 61 miles an hour? Come on.
I mean, yeah, 80 to 90s, really, major league player, that's pretty good.
I could still throw 60 miles an hour.
Now he's bragging.
I'm pretty sure I could. 60 miles an hour is not very fast. It's not. Most of your high school pitchers can throw like 75 to 80. I could still throw 60. I'd have to warm up. I'm getting, well, put it this way. I know 10 years ago I could still throw 60 miles an hour. I don't know about today if I could do it. Yeah. It'd probably be hurting by the time I got warmed up enough to throw that. Most of you, I bet, could probably still throw 60 miles an hour too. Unless you throw like a girl. Right? It wouldn't shock me, Brennan. It wouldn't.
We should test and see who can go the fastest with their opposite.
Actually, I used to be pretty good throwing left-handed.
I think everyone
Looks a little weird.
Yeah, they look kind of. I used to switch bats when I played softball. I'd use both sides. What is that called?
Okay, so let's look at another example of these. Let's look at, let's say that you have a material that's listed as having 2.1 ounces per cubic inch. Then you want to know what's that going to be in pounds per cubic foot. Well, it's 2.1 ounces over 1 cubic inch. Whenever you see that, you always put it over one of those units. We're going to convert the ounces. Where are the ounces going to go here? On bottom, so they cancel out. Your pounds on top, because you're moving the ounces to pounds. 1 pound is 16 ounces. You look confused.
Where do the feet go?
Where do the feet go? Well, we want to get rid of the inches, right? So the inches are on bottom. Actually, cubic inches are on bottom. So we're going to put cubic inches on top, which means the cubic feet are going to go down here. Because we want them to be on bottom. So it's good that they're on bottom. So the cubic inches are going to cancel out. 1 cubic foot is how many cubic inches? Remember, 12 by 12 by 12. 1,728. 12 times 12 times 12, 1,728. So now the cubic inches have canceled out, the ounces have canceled out. We have pounds per cubic foot. We have 2.1 times 1,728 is 3628.8. That unit is pounds right now. And on bottom, we've got 1 times 16 times 1, so that's 16 cubic feet. So we just need to divide that by 16. It was 226.8 pounds per cubic foot. So 2.1 ounces per cubic inch is 226.8 pounds per cubic foot. Make sense? Okay. Yep. Because it's a bigger volume. You're going to 1,700 times as much volume. So in that packet I gave you, on page 238, you should be able to do 51 through 64. And on page 266 in that packet, 49 through 62.
6666, huh?
266. There, 266. Sorry about that. I don't know where that came from.
I don't know where it came from. Doesn't watch it very well.
There you go.